Station 1. What type of mixing is happening? How do you know? Additive primary colors was the mixing, and I know that because it was the slide colors were red, green, and blue, and when those three colors would overlap, the center at the point in which they'd overlap, a white light was formed. Station 2. What type of mixing is happening? How do you know? Complementing colors was the mixing, and I know that because only two of the three colors were needed to produce that white light. So the colors used were cyan, magenta, and yellow. And so if we just use cyan and magenta, a white light would be formed, or magenta and yellow, a white light would be formed, and that's how I found out that it was the complementary colors. Station 3. Explain why a rainbow emerges from the prisms. A rainbow emerges because of refraction, and it's as the light enters the prism from an angle, uh, the glass causes a light to travel slower. So, because of that, the speed is affected by the frequency of the light. And so, each frequency is slowed down by a different amount. And so, because of that, uh, that causes the colors to separate and form the rainbow. Station 4. Explain why you see the American flag with correct colors. Uh, well, we would, when I looked onto the white paper, I saw the American flag with the right colors because it's like my receptors are fatigued, and because of that, they send a weaker signal to my brain. So when that happens, it's like I see what I want to see. So the white paper minus a color, so looking at the white paper with no color, it produced the complementary to the missing color. So the flag was, I think, yellow with black stars, and so because I stared at it for so long, like my receptors became like used to it or whatever, and so when I moved to the blank white piece of paper, the image was formed in my mind, so I just saw the colors. Uh, Station 5. Give one reason why you think the optical illusions are possible. Um, I think they're possible because we don't see things how they are. We see them how we don't okay. We don't see things how they are. We see them how we are. So we're so used to just like zooming by things that we don't actually take the time to look at it. So what I mean by that is that when we read something and it had like the two words, I think it had that in the sentence twice. And so it was supposed to fool you because we just zoom by and read it. So by that, like it's able to fool us or whatever because we don't actually take the time to like stop. We just like automatically do what we think it's going to be. Station 6. Why is the amount of light passing through two filters change as you rotate one filter? Um it changes because light will pass through polarized filters only if their polarization axes are aligned, and so uh if they're at right if their axes are at right angles to each other, it won't show. So that would happen when we rotate them. It'd become at right angles, and then we wouldn't be able to see through them. Why does having a third filter diagonally in between the first two filters allow light to pass through all three? Well, because the polarized filters can't be at right angles to each other, by putting that third filter in between them, it made it so that none of the filters were at right angles with each other, and so that's why we are able to see through it. Station 7. Why does it appear as though the test tube with oil disappears when placed in the beaker with oil but not water? Um, the be- the test tube with baby oil has an identical index of refraction to the baby oil in the beaker, and so the baby oil, it's the same thing. So when I dipped the test tube of baby oil into water, they weren't the same. So I was able to see that the difference. But when I dipped it into the test tube filled with baby oil, when I dipped it into the beaker full of baby oil,